Hello and welcome to the Royal Observatory Greenwich's moon viewing live stream. My name's Dr. Greg Brown, one of the astronomers here at the observatory, and this evening we are going to be making use of our Annie Maunder astrographic telescope to get as good a view of the surface of the moon as we possibly can on the 50th anniversary of the launch of Apollo 17, the last time that humans went to the surface of the moon. Well, we have been blessed this evening with an extremely cold but remarkably clear night, which means that this is in fact already the view through our Annie Maunder astrographic telescope, a brilliant, stunning full moon, so as big and bright a moon as you are likely to see. And we're going to be having that up on the screen through most of the rest of this live stream, our live view through our own telescope. Now, in this live stream, we are going to be talking about observing the moon all the way from early unaided observations without the use of telescopes, through cameras, photography, and then on, of course, to the exploration of the surface of the moon from orbit and on its surface. We're also going to be talking about what's going on right now, the missions to the surface of the moon, one of which is currently on its way back from the moon at this point. And we'll also be taking a quick look into the future of human exploration. Now, throughout the entirety of this stream, we're also going to be monitoring our YouTube and Facebook chats, so please do send in any questions that you might have about space and astronomy, and we'll try and answer as many of them as we can during this stream. So, we are going to be observing the moon today through our Annie Maunder astrographic telescope. And to tell us a bit more about the telescope that we're going to be using, we're going to be hearing from Tanya, another of the astronomers here at the observatory.
Hello, my name is Tanya and I'm one of the astronomers here at the Royal Observatory Greenwich, and I am going to be talking to you about the instrument we'll be using in today's live stream. We'll be looking at the moon, and of course you can see the moon with your eyes. However, if you use a telescope, you get to see lots more detail, like craters and mountains on the surface of the moon. We are going to be using AMAT, and AMAT stands for Annie Maunder Astrographic Telescope. And Annie Maunder was a pioneering astronomer that worked here at the Royal Observatory Greenwich in the late 19th century. Now, AMAT is actually made up of 4 telescopes on one mount, and it's a robotic mount, which means that it follows the sky. So as the Earth spins on its axis, our view of the sky changes. And if you have a robotic mount, then you're able to track that celestial object that you are observing automatically. We are going to be using this telescope here, the 120mm aperture refractor. And the refractor telescope is a telescope that uses a lens rather than a mirror to gather the light. And the 120mm aperture just means that that's the size of the light gathering lens. We're not going to be looking through the eyepiece. We're actually going to be using a camera, which is why this is called an astrographic telescope. And the camera actually will allow us to see images of the moon throughout today's live stream. Now, because the moon is really bright, we have to use short exposures. And if the weather clears up, then we'll be able to get a beautiful view of our celestial companion.
Tanya there, one of the other astronomers here at the Royal Observatory, talking about the Annie Maunder astrographic telescope, the telescope we are going to be using to observe the moon. If you're just joining us, this is the Royal Observatory Greenwich's moon viewing live stream, which is celebrating the 50th anniversary of the launch of Apollo 17, the last time that humans went to the surface of another world. And this is our view through our Annie Maunder astrographic telescope at the moment. We've been blessed at the moment, at least, with clear skies, a fantastic view of these darker regions on the surface of the moon, the Maria, or the seas, which we'll be talking about a bit later on. You can also see details like the surface, carved out giant holes. And you can see the whiter regions, those are the lunar highlands. They're more rugged, higher up parts of the surface of the moon. Now, throughout this evening's live stream, we're going to be collecting questions that are coming into our YouTube and Facebook chat. So please do feel free to put any question you'd like to know the answer to about space or astronomy, and I will do my absolute best to answer as many of them as I can throughout this stream. Now, over the many, many centuries that we have been observing the moon, the vast majority of the time, we have only had the ability of our own eyes. And our eyes are great for seeing many, many things, but seeing things which are relatively faint and far away is not one of them. And while the surface of the moon is extremely bright, seeing detailed features on the surface is beyond us. So it wasn't until the early 1600s that the telescope, then suddenly a whole new wave of discoveries were made. And one of the people who was instrumental in these discoveries was, of course, Galileo Galilei, one of the first people to observe making use of a telescope. He observed the moons of Jupiter, the rings of Saturn, and also made some fairly detailed images of the surface of the moon, and that's what you're seeing right now. Now, these are drawings, they're sketches from Galileo's notebooks. And even though not all of the features absolutely line up with what we expect to see, most of them are exactly what we are expecting. You can see the large dark regions, you can see some of the craters coming through, you can also see some of the different phases of the moon when the moon is being lit up by a different amount. Now, drawings are great, but ideally what we really want is to be able to get whatever's coming through the telescope to come directly to a recordable image. In other words, what we really want is a camera. And the camera was invented in the early to mid-1800s, and even in those early years, camera observations of the moon were really popular. Now, the oldest images that were ever taken of the moon, at least that we know of, were lost relatively shortly after they were made. But sometime later, in the 1850s, we do now have the oldest surviving image ever taken of the moon. Taken by John Adams Whipple, this was a very, very early attempt at lunar photography. And while the image has clearly had some serious damage done to it over the course of the years, it is still an absolutely fantastic image of the surface of the moon, and absolutely matches up with what we are seeing now through our own Amymanda astrographic telescope. We can see the same dark regions. In fact, that dark region that you are seeing in the top right-hand corner of your image right now, that is the Maria, the sea, those dark regions that was on the left-hand side of John Adams Whipple's image. So we've got photography, but it's still very, very early on. In the modern day, we have a wide range of far more sophisticated pieces of equipment capable of taking extremely detailed images of the surface of the moon. And many of these are available to anyone who wants to try astrophotography for themselves. Now, here at the Royal Observatory, we run the Astronomy Photographer of the Year competition. It's the largest astrophotography competition in the world, and one of the many categories that we have is one for our very own moon. Now, there are a whole range of absolutely brilliant entries into that competition this time round, but there's one in particular that really works for the image that we are getting today through our telescope. And to tell you more about it, who better than the man who took the images in the first place?
Io riprendo principalmente dal mio giardino perché comunque i miei setup sono parecchio pesanti da trasportare, quindi trovo più comodo riprendere vicino casa. E la luna è molto facile da riprendere nella mia zona perché fortunatamente sale sempre sopra le case che ho vicine in modo importante e quindi non ho problematiche evidenti. L'immagine che è stata selezionata per la shortlist è Moon Big Mosaic. La difficoltà nel riprendere un grande mosaico lunare sta nel trovare le stesse condizioni per tutta la durata della sessione, per avere tutte queste singole immagini con uguale incisione. Il secondo problema legato appunto alla creazione dei mosaici lunari è l'unione di questi mosaici che deve essere fatta accuratamente e in modo manuale. Ovviamente l'astrofotografia non è solamente la parte principale della mia passione per l'astronomia, ma ho anche un gruppo di amici con cui guardo le stelle, con cui riprendo la volta celeste e con cui mi ritrovo regolarmente per condividere la nostra passione. Come lavoro faccio l'educatore in una cooperativa che lavora con la disabilità e mi piace ogni tanto portare il mio telescopio per far osservare ai nostri ragazzi il cielo sopra di noi. Il mio desiderio è quello di portare l'astronomia a grandi e piccini, in modo che questa grande passione possa essere non solo mia e di tanti altri, ma anche di tantissime altre persone.
Moon Big Mosaic, an absolutely fantastic, vast image of the surface of the moon there, and a brilliant image in our astrophotography competition. If you're just joining us, this is the Royal Observatory Greenwich's moon viewing live stream. My name's Dr. Greg Brown, and we're going to be showing you the best images that we can get through our Annie Maunder astrographic telescope. And we've been blessed this evening with brilliantly clear skies, which means that we have this stunning view of the full moon. Now, throughout this live stream, we're going to be taking your questions and answering as many as we can. If you are watching us through YouTube or Facebook, please feel free to put any questions that you have into the chat and we will answer as many as we can. And we have had several questions already. So one question that we've got is, why does the moon appear so much bigger when it first rises? Well, that's a really interesting question. It's actually an optical illusion. It's not that the moon is actually bigger in the sky. This actually has its own name, called the moon illusion, and it's basically something to do with the way that your mind processes the images that you see. When the moon is high up in the sky, you've got nothing to compare its size against, and so it appears a certain size in the sky. But when it gets lower and lower and lower in the sky, your mind attempts to match it up with various other objects on the skyline, and thus it makes it appear considerably bigger than it actually is. So yes, if you've seen a really, really big moon low down in the horizon, you're not seeing something unusual, it's just your mind playing tricks on you, which is very, very weird indeed. We've got another question. Why do we see the moon in the daytime as well as the nighttime? Yes, this is a common question. We often associate the moon with the nighttime, and certainly it's easiest to see at night when it becomes pretty much the brightest light that we can see when it's around. But we don't just see the moon at night. Sometimes we don't see it at night at all. The moon moves around the Earth. It orbits around our planet Earth. And the only reason that we can see the moon at all is because it's being lit up by the light from the sun. Now, sometimes the moon will be in the right place in order for the entirety of the side facing towards us to be visible. And that's what we've got right now. That is the full moon, where we can see the entirety of this side of the moon being lit up. But sometimes the moon will be slightly to one side of that or somewhere else in the sky in relation to the sun. Now that means we'll only see a smaller part of the moon being lit up, but also that means that it will share the sky with the sun at some point during the day. And when this gets most extreme is when we get to the new moon. The new moon is when the sun and the moon are roughly lined up with us on the other side. So the moon is almost, but not directly, between the sun and the earth. And when that happens, the moon, from our point of view, pretty much disappears. We're seeing the dark part of the moon, the bit that isn't being lit up by the sun. But that also means that it's almost right next to the sun when it does so. So in fact, if you could somehow see the new moon, which is unfortunately really very difficult without specialized instruments, you would be able to see the moon right next to the sun in the sky during those days. We've got one question here. Why does the moon seem like it gets hit more than the Earth? So this is what we're referring to as craters. So across the surface of the moon, it's a very, very scarred landscape. There are clear signs where rocks from space have smashed into the surface and carved out giant holes. And it certainly looks as though the moon has been bombarded so much more than the Earth. But actually that's not entirely true. We have a vast number of craters on the surface of the Earth. It's just there are a lot of ways to either hide or get rid of those craters here on Earth. 2/3 of the surface of our planet Earth is covered in oceans, which means any craters that occur in there will actually disappear from view. Any craters which are covered up by vegetation, they'll disappear as well. We have wind, we have rain, which washes away and rubs down those craters, gets rid of them, eroding them over time. And we also have plate tectonics, so the entirety of the surface of our world is constantly being recycled over the course of a few 100 million years or more. Which means that none of the rocks on the surface of our planet are older than a few 100 million years. Whereas when we look at the surface of the moon, we are seeing rocks all the way back to 3, 4, 4.5 billion years. We're seeing the entire record of everything that's hit it, whereas on the Earth, we only see the last little bit. So it's not so much that the Earth hasn't been hit as much as the moon, it's just we've got ways of clearing out those craters that the moon just doesn't have. If you have any more questions, drop them into our YouTube or Facebook chat. We'll be answering more as we go through our live stream. Now then, as brilliant as it is to be able to take images from here on the surface of the Earth, there really is no substitute for getting up close with whatever it is you're trying to study. But for an extremely long time, that was of course not possible. It wasn't until the 1950s, when the rocket was produced, that finally we could start to head out into space and explore for ourselves. And of course, the moon was going to be one of the first targets. And in the early 1960s, one of the pioneers, of course, was the Soviet Union, sending rockets up into space, including Luna 3. Now, Luna 3 took the first image of the far side of the moon. Due to a weird quirk of the way that the moon orbits around the Earth, it actually always keeps one side facing towards us and one side facing away. Which means the view that you can see through our telescope, that's the near side. The view that Luna 3 got, that's the far side, the bit that we can never see from here on Earth. Now, the view that Luna 3 got is certainly blurry. There's a lot of distortion in the image, but some features are coming through. Those dark regions, the maria on the surface, are clearly visible, and yet there are clearly far, far fewer than there are on the near side. And that is a mystery that remains to today. Although there are theories about why there are more of these dark regions on our side of the moon than on the other side, it's unclear exactly why that is. Once we'd gone out into space and started orbiting around the moon, we were, of course, going to try to land. This was the beginning of the space race, the competition between the United States of America and the Soviet Union to get the first person on the surface of the moon. And while the Soviet Union was off to a fantastic start, ultimately it was going to be the United States of America that landed the first person on the moon. Now, these were through the Apollo missions, and in total there were 6 successful missions that actually landed on the surface. And they landed in a whole variety of different places on the surface of the moon. And this was deliberate. It was to try to get as many different samplings of different places on the moon as we could manage. Now, 7 missions should have landed on the moon, but of course Apollo 13 unfortunately didn't manage to land before an accident occurred and they needed to be brought back to the Earth. But all of the others, from Apollo 11 all the way through to 17, did manage to land on the surface of the moon. Apollo 11 landing in Tranquility Base, part of Mare Tranquillitatis, which is the Sea of Tranquility. And Apollo 16, a very, very different place, landing instead in the lunar highlands, those bright white regions on the surface of the moon, much, much higher up, and we think considerably older as well. Now, getting to the moon is no easy task. The main problem, of course, is the gravity that we have here on the surface of our planet Earth. And that means that you're going to need a really big rocket to get whatever it is you want off the surface of the planet out into space. And from that point forwards, relatively speaking, it becomes a bit easier. In order to clear our atmosphere, the Apollo missions went for the Saturn V rocket, at the time by far the largest rocket that had ever been produced, and still one of the most powerful rockets ever to have been produced. Now, this rocket was mainly for that initial process, getting off of the ground and heading up into orbit. Then a much smaller set of capsules continued on their way to the surface of the moon before the lunar lander went down to the surface and came back up with the astronauts when they were completed with their mission on the surface of the moon. Now, one of the things that is sometimes said about the lunar missions to the moon is that it's been claimed over the years that they never actually happened, that somehow this was some huge conspiracy. And one of the pieces of evidence that's been used to try to claim that is an apparent lack of images of the surface of the moon with remaining parts of the lunar lander, the footprints, all those various other things taken from the surface of the Earth. And while the conspiracy is absolute nonsense, there was a very good reason why those images didn't exist. Trying to see the surface of the moon 400,000 kilometers away and seeing something that is only a few meters across is a bit like trying to take a telescope and look at a coin on the surface, on the top of a mountain many, many miles away. It's extraordinarily difficult. But more recently, that problem has gone away. And it was solved by a probe called the Lunar Reconnaissance Orbiter. Instead of trying to take images from the surface of the Earth, 400,000 kilometers away, this probe went out into space and is actually orbiting around the moon, doing detailed images, surveys of the surface of the moon. And this is its image of the Apollo 11 landing site. On the left-hand side, you have those dots. Those are, in fact, the lunar lander itself and some of the instruments that were left behind. But really interestingly, you can also see the footprints left behind by Neil Armstrong and Buzz Aldrin as long trails, very much like trails in the sand of the desert, going out on their EVAs, their attempts to walk across the surface of the moon. Now, the Apollo 11 mission actually didn't last all that long. It was very much testing the water, seeing if all of this was actually possible. The main thing was to land on the moon, have an EVA, make certain that everything was going to be fine, and then get them back nice and safely. And so we've got this image of them on the surface of the moon as well. They did do some science while they were there, leaving behind objects such as this. This is one of the seismometers that were left on the surface of the moon. On Earth, a seismometer is an instrument which is used to detect earthquakes. Of course, on the moon, they would instead be moonquakes. They also left a number of reflectors, mirrors, that would enable us to, later on, bounce a laser from the surface of the Earth out to the moon and then back again. And one of the key discoveries that comes from that is we can determine exactly how far the moon is away by how long it takes that light beam to travel from the Earth to the moon and bounce back again. And from that, we've realized that the moon is actually slowly moving away from us at about 3 centimeters every year. That's about the rate that your fingernails are growing. So even though this was very much an early test of the water, this was still a mission with important scientific objectives. Fast forward now to Apollo 17. This is 1972, 3 years after the first Apollo 11 mission. And 50 years ago, this morning, Apollo 17 was launching out into space. It spent about 2 or 3 days in space on its way to the moon before landing the lunar module down onto the surface of the moon at the Taurus Littrow Valley. This is a rather different place to Apollo 11's landing site. Whereas Apollo 11 was very much in the bottom of one of these maria, these dark regions on the surface of the moon, the Taurus Littrow Valley was a much more rugged, much surrounded by craters, valleys, all sorts of things going on. And this was again to give as much of a wide sampling of the surface of the moon as we could manage. They landed on the surface of the moon and spent about 3 days on its surface and about 24 hours actually doing EVAs. And this considerably longer mission allowed them to do a lot more. They took along with them the lunar buggy, an attempt to have a car to actually travel across the surface and enable the astronauts to actually explore much, much further away from their initial landing site, which is precisely what Gene Cernan and Harrison Schmitt did during those missions. And we haven't been back. Not in almost 50 years at this point. But the legacy of Apollo is still extremely impressive. We have a vast amount of information that's been collected from the various things that they did on the surface of the moon. And a lot of it relates to the exact sort of things that we can see here on the surface of the moon right now. These dark regions that I've been mentioning all the way through, these maria, these seas. We call them seas because ancient astronomers, when they looked up into the night sky with their own eyes, they weren't certain what it was they were looking at. And they thought that maybe, just maybe, that might be what oceans look like from very, very far away. We now know, of course, that they were wrong. These aren't oceans at all. They're very much solid rock, volcanic rock. But strangely enough, at one point, they were right. They were oceans. They were seas. But not seas of water, seas of lava on the surface of the moon. You see, these are the low-lying regions. They are the bottom of valley floors, much lower regions on the surface of the moon. And for some reason, we're not entirely certain why, probably associated with lots of impacts from rocks from space, lava erupted out of the bottom of these low-lying regions, filled them up, and made them into vast seas of lava, which of course eventually cooled down and formed the volcanic rock that we see today. That also means that these regions are considerably younger. If you take a look at the dark regions on the surface of the moon, they have far fewer craters than the much lighter regions of the surface of the moon, which have considerably more. And that makes sense. Any craters that occurred during those early times before these became seas and then eventually solidified lava on the surface of the moon, all of those craters are long since gone. But the highland regions have stayed effectively pristine, still covered in all of the craters that they had. Now, we've got all sorts of examples of different features on the surface of the moon. You can see some of the larger craters on the surface of the moon as well, these rays of white rock that have erupted from the surface when an impact occurred, when this rock smashed into the surface. One other thing that the Apollo astronauts were doing was collecting vast numbers of samples of rock. They brought back almost 400 kilos of lunar samples. To put that in perspective, the largest robotic mission that has ever gone to the surface of the moon and then brought back a sample brought back about 100 grams. So the human missions, the expeditions to the surface of the moon with people on them, brought back far, far more samples. And all sorts of interesting things came out of that. One particular sample found on the surface of the moon was a vast chunk of rock that one of the astronauts thought was a nice thing to try and take back, a sample to bring back, only for us to discover that actually it was a meteorite, a rock that had landed on the surface of the moon from space. Where had it come from? The Earth. Sometime in the past, some huge collision smashed into the Earth, sent chunks of rock up into space, and then eventually landed back down on the surface of the moon. And then, several billion years later, a human from Earth went up onto the surface of the moon, picked up the chunk of rock, and brought it straight back to the Earth. An absolutely fascinating story of an extremely long journey for one chunk of rock. One other thing that the Apollo astronauts managed to do is finally, with the evidence that they provided, determine how the moon was formed. In our solar system, there are a vast number of different moons, about 200 around the various planets of our solar system. And they formed in all sorts of different ways. Some of them formed completely independently of their planets, being captured by the planet much, much later on. That's usually true for some of the smaller objects that we found around some of the bigger planets. Some of the planets instead produced their own moons, the leftover stuff from those planets being spread out into a disk and then forming their own objects. And again, this is true for some of the bigger objects around some of the larger planets of our solar system. But we didn't know how our moon formed. We weren't certain. And it turns out the answer was none of the above. Instead, we now know that almost certainly the moon was formed from a vast collision between the Earth and an early planetesimal about the size of Mars, nicknamed Theia. That object smashed into the surface of our Earth when it was still molten. It had only just been formed, threw material out into space, which then collected together to form the moon that we see today. And one of the key pieces of evidence of that is actually the lack of iron and nickel on the moon. Iron and nickel is a really important part of our planet Earth. It forms a vast core at the center of our planet. But the moon is comparatively light. It doesn't have that iron-nickel core. And that's actually a sign that the object formed after the Earth did through some collision that scraped off the upper layers of the Earth but left the iron and nickel core at the center pretty much undisturbed. The legacy of Apollo is absolutely fantastic. It's been one of the most televised events ever seen, was the Apollo 11 landing. But even just 3 years later, with only the 6th time of people landing on the surface of the moon, interest in moon landings had waned. It wasn't as interesting to the general public as it once had been. And that's a shame, because the interest amongst the general public nowadays is still very, very high. But even more than that, the amount of science that we can still do on the surface of the moon is astounding. The good news is that all of that, 50 years of no exploration of the surface of the moon by humans, is about to change. And who better to tell you all about that than NASA themselves?
3, 2, 1, 0. Mission liftoff.
Artemis 1 will lift off from Launch Pad 39B at NASA's Kennedy Space Center in Florida with 8.8 million pounds of thrust, provided by the most powerful rocket in the world, our Space Launch System rocket, or SLS. The uncrewed flight will be the first integrated test of SLS, our new Orion spacecraft, and exploration ground systems at Kennedy. Artemis 1 will send Orion beyond the moon, 280,000 miles from Earth, farther than any human spacecraft has ever flown.
This is not NASA doing this. This is the United States of America doing this program, the Artemis program, and there are companies all across our country that have a part in it, so there is kind of this wave of excitement being generated just by saying, we're going back to the moon.
After the upper stage of the rocket separates from Orion, the upper stage will deploy small satellites over several days to perform science experiments and technology demonstrations. Orion will make its multi-day outbound trip to the moon, propelled by a service module provided by the European Space Agency. Engineers will test Orion's systems on the way to the moon. Then, Orion will fly about 60 miles above the lunar surface, using the moon's gravity and engines on the service module to enter a lunar orbit. After about a month and a total distance of over 1 million miles, Orion will return home, faster and hotter than any spacecraft has before. A primary goal of Artemis 1, ensure Orion safely returns to Earth before we fly with humans. When we do, we'll build our capability for sustainable lunar exploration, preparing us for missions farther into the solar system.
Initially, what we'd like to do is start establishing a presence on the moon. So we're going to establish going back there on a regular basis, and then we'll end up setting up Gateway, and we would launch to the Gateway, and from Gateway land on the surface of the moon.
We are there for weeks, months on end, And there, we're going to be able to test out all the hardware and the habitats and the hatches and the suits and the rovers that'll allow us to prove out those technologies.
The Artemis missions, our next big chance to go to the surface of the moon, are in fact happening right now. That video was made about a year ago, so it's now somewhat out of date, but in fact, Artemis 1 is actually going around the moon at the moment. It launched a little under a month ago, a few months later than it was intending to, but nonetheless still well within time. And it launched on the Space Launch System, again, one of the most powerful rockets that has ever been produced. And it spent about the last month orbiting around the moon, basically, again, testing the water very much like Apollo 11 was doing all the way back in 1969. Now, while Artemis 1 has been up there, it hasn't been crewed. There hasn't been any people on this mission, nor has it actually touched down on the surface. But one thing that it has done is that it's gone further on the other side of the moon than any human-capable mission ever has before. And it's been live streaming a lot of its progress through space, which has resulted in some pretty impressive images, including one of my favourites, which is this one right here. You can see the Orion module in the bottom left-hand corner, but those two objects in the top right, that's the really interesting bit. That is the moon on the left-hand side and, of course, the Earth on the right. Now, the moon is actually a lot smaller than the Earth. This is a simple case of the Orion being a lot closer to the moon in this image, which is why it appears a fair bit bigger. But what's really interesting about it is the colour of the moon in this image. We are so used to seeing the moon as this extremely bright orb of light in the sky. If you were looking at the moon this evening, you might be blinded by how incredibly bright it is. And yet, in reality, that's something of an optical illusion as well. When we observe the moon, we're almost always doing so by observing a very bright object in otherwise very dark conditions. Our eyes are set to see something dark, and yet we're looking at the moon, which is extremely bright, and the result is that it looks like this massive glowing white object. But in reality, the surface of the moon is remarkably dark, not that much lighter than tarmac or asphalt. It's a remarkably dark place on the surface of the moon, which is why it seemed so much darker in that particular image that we saw right there. Now, throughout this live stream, we've been collecting in your questions through YouTube and Facebook. And I've got some of the questions with me right now, and we're going to try and answer as many as we can. One question that we've had asked is, how old is the moon? Well, the moon is almost as old as the Earth is, almost 4.5 billion years, when the moon formed during that vast collision between that rock named Theia, about the same size as Mars, and the early Earth. The early Earth was still very much molten. It had only just been formed. So the moon is actually almost the same age as the Earth was. But instead of some of the other moons, which were formed alongside their planets, this one was formed as a direct result of a collision between our planet and one that was never going to be a planet. Another question we've got is, are there any mountains on the moon? Are there any moons on the moon? Yes, there are mountains on the moon. A vast array of mountains on the surface of the moon, kilometers tall. A lot of these mountains are actually found in the middle of some of these craters. It's almost like if you drop a rock into a pond, you might get a ripple of water coming back the way that the rock travelled, bouncing up into the sky. And it's almost the same sort of thing. Some rock smashes into the surface of the moon, carves out this giant hole, but there's also this big splashback of rock in the centre, and that produces some absolutely vast mountains on the surface of the moon. Next question we've got, what would happen if the moon disappeared? Well, the good news is there's no sign of that happening. Yes, the moon is moving away at about 3 centimeters every year, but it's 400,000 kilometers away, which means it's going to take a very, very long time to get any serious distance away from us. But if the moon did disappear, it would be an interesting thing. First of all, the tides that we have on the surface of our Earth, most of them would disappear. The tides occur due to the gravitational influence of some of the other objects in our solar system, namely the moon and the sun, the ones that cause by far the greatest gravitational pull. And the moon provides most of it. So our high and low tides, most of that would disappear. We'd only be left with the tides associated with the sun, which are quite a bit weaker. One other interesting thing that might be true, and we're still not certain of this, is it's been suggested that the presence of a decently sized moon is actually necessary to stabilise the spin of certain planets, and that, strangely enough, that might actually be a key important factor in the search for life. It's possible that if a planet doesn't have a stabilised enough spin, that it might not be suitable for having life. Now, this is very much up in the air. We still don't know whether this is true or not, but even if we did lose our own moon, well, it's not as though life would disappear overnight, and indeed it might have no real effect whatsoever on the life here on Earth, except that the oceans will not be being stirred up through the regular tides that we get at the moment. We've got one question here. Do you suffer in your location with light pollution, and are you able to filter it out? So we are lucky enough to be here in the middle of Greenwich Park, which is one of the larger green spaces, dark spaces in this area. And so light pollution is not as big a problem for us as it is for certain people in the surrounding communities. But nonetheless, we are still in London. We have Canary Wharf just over the river, and of course the main city of London to the northwest of us. So light pollution is absolutely a big problem here at the Royal Observatory, and is one of the reasons why research isn't something which is done so much here at the observatory anymore. But yes, there are actually ways to try to filter out some of that light pollution. You can use certain filters that target the specific colours of light that are worse for light pollution, but still let through plenty of the other types of light which the objects you're trying to look at are bright in. So that's potentially one way to try and deal with it. Now, this evening, we actually don't have that problem at all. Under normal circumstances, I would be standing in a very, very dark room observing some object in the night sky using this telescope. But today, we've got no problem setting up these lights because we are, of course, looking at the moon, an extremely bright object, to the point that not just light pollution isn't a problem, our own studio lights here aren't an issue either. And finally, the last question we're going to answer today is, if we landed on the moon 50 years ago, why haven't we been back since? And it's a very, very complicated question. One of the most important aspects, of course, is money when it comes down to it. The missions to the surface of the moon costed a vast fraction of the entirety of the GDP of the United States of America during that time. And the budgets of scientific institutions like NASA are considerably lower compared to the country's finances nowadays than they were back then. And that means that any mission to go to the moon is going to be difficult to do, and we need to make certain there's enough support behind it, enough reason to go in order to do so. One of the other reasons that the entire set of missions happened in the first place, the Apollo missions, is that there was a lot of political motivation behind it. And once the effort had been achieved, from that point of view, there didn't seem to be much point in going back. But as I've said, in fact, from a scientific perspective, we have barely scraped the surface of the moon, quite literally, and we want to head back in order to explore it even more. And that is where the Artemis missions are coming in, with our next step to head to the surface of the moon. But that's not where Artemis is going to end. Artemis is just the beginning of us heading back to the moon. Artemis 1, this uncrewed mission without people on it, without landing on the surface of the moon, just testing the water before we move on to Artemis 2, which will be a mission which actually has people on it, but again won't land on the surface, basically the equivalent of Apollo 10 during the Apollo missions. And then finally, Artemis 3, the mission that's actually going to land on the surface of the moon, currently slated for about 2026. Even if it slips a bit, chances are we will have a person on the surface of the moon by the end of this decade. But that's not where it ends. Artemis is very much a set of missions intending to go back to the moon and stay there. And part of the way that they're going to do that is through Gateway. Gateway is going to be the first space station to be orbiting another world, in this case, orbiting around the moon. It's like a small version of the International Space Station, which can act as a drop-off point to the surface of the moon, but also as a stepping stone to something even more impressive. If you've been observing the moon today through your own telescope, if you've been looking at it with your own eyes, then chances are you might have noticed a deep orange-red object just to the left of it. And that, as it turns out, is the planet Mars. Now, the planet Mars is the hope of the next step in human exploration. It is this tiny, almost insignificant compared to the moon, little orange-red dot. But what it represents is a far, far greater challenge. What we think, over the course of the last 50 years, when we've been going up into space, we have been going only as far as various space stations about 400 kilometers above our heads. The International Space Station and Mir and various others. Going back to the moon with Artemis, that is 400,000 kilometers away, 1,000 times more distant. Whereas getting to the International Space Station takes maybe a few hours, getting to the moon takes 2 or 3 days. But going to Mars, that's tens of millions of kilometers away, or 8 months of constantly traveling through space. The technological implications of that, the problems that are going to be encountered, are astronomical, quite literally. And it's going to be an incredible effort to get there, but definitely something that we want to do. We're now coming to the end of our moon viewing live stream this evening. I want to have a big thank you to Jake, who's been operating the telescope for us in the background, to the AV crew and the web crew who are currently below me in the telescope dome, who've been absolutely fantastic, and also to all of you who have been watching this evening. We very much hope that you enjoy the rest of this evening. Good night.